we're talking about normal, or as it's known, Gaussian distribution. And usually we note this type of distribution as n, mu, and sigma, which is, if you remember, we said it is only required to have mu, mean, and a standard deviation or variance of the distribution in order to draw it. In some books, they show it with g, mu, and n, which is the same. And if you remember, it had the shape like this. It's symmetric around mean. It is symmetric around mean, and we understand that if we are making the sigma smaller, in other words, it's like that we are squeezing this one, the maximum value will go higher. Why the maximum value will go higher? Because we said that this is the PDF. The area underneath this curve is 1. Right? The area underneath this curve is 1. Now, because it is symmetric, can you tell me that what is this area? Yes, exactly. The area here is 0.5. But can you tell me the probability the interpretation of the probability of this area is 0.5. What is it? The interpretation from probability point of view. What do we understand? I mean, if you want to talk professionally, you have taken this course and you want to say something. What does it mean? What does the area underneath the probability means? Let's put it in this form. I have a graph like that. I have not a PDF like this. This is my PDF. From A to B. What does this area represent?
The summation of all values before the mean.
No.
The mean.
What does this mean? We know that this area shows the probability, right? What probability?
Of values between A and B.
The value of B between A and B.
Yes. The value, this is the probability that a random variable is between A and B. Right? Now, this is, did I give any specification about PDF? No, so it's very general. It's very general. So knowing this, can you tell me that what can I write in here? A random variable has this distribution.
Probability that random variable is more like mu.
Is less than 0.5, greater than minus infinity, which we don't write. So this is, I wrote 0.5 and I meant mu. The probability of x is less than mu, whereas we know it starts from minus infinity, you can always put equality, we know this is equal to 0.5. This is equal to 0.5. Now, similarly, we can have this. Because it's symmetric, so it means it divides the things into 2, so this probability is also 0.5. Which means the probability of x is greater equal than 0.5, greater equal than mu, it is equal to 0.5. And obviously, we can all understand that the probability of x is equal to mu is equal to 0 because the area underneath one point is 0. So we knew this because we know it's symmetric around mean. So let's see what will happen if we want to calculate the probability of x less than or equal to some specific value or greater than some specific value. But before getting to that point, we have to note that from here we can obviously understand the probability of x less than equal to alpha, whatever the alpha is equal to 1 minus, actually in the book it's written in this form, the probability of x greater equal or greater than alpha is equal to 1 minus the probability of x is less than equal to alpha. Here you can see that the probability of mu greater, x greater than mu is 1 minus the probability of x less than mu, which is 1 minus 0.5, which is 0.5. So this is due to this fact. This is due to this fact. Imagine this is alpha. Imagine this is alpha. This is probability of x is less than or equal to alpha, right? And this part is probability of x is greater than alpha. And we know that because the area underneath this PDF, it's a PDF, is 1, so probability of x is less than or equal to alpha plus probability of x is greater than alpha is equal to 1. So we understand that they are kind of a complement. Probability of x is less than alpha if x is a random variable with normal distribution of mu and a standard variation of sigma is, what was the formula for normal distribution? 1 over square root of 2 pi sigma from minus infinity to alpha of e to power minus x minus mu square divided by 2 sigma square dx, right? Calculation of this integral is not easy. This is one of those integrals which you cannot use by part or substitution technique. You have to use some numerical analysis in order to estimate what is the result of this integral. However, we have a table which I just distributed at the beginning of the class which we can use it. But in order to do that, we have to talk a little bit more. However, we can calculate this integral by using the table which is for a random variable, let's say z, whose distribution is a normal distribution with mean 0 and a standard deviation of 1, also known as a standard, or in some book they call it normalized Gaussian distribution. So they call it normalized Gaussian distribution or a standard normal distribution. So we have a table which can tell us what is the result of this integral. What is the result of this integral from minus infinity to alpha? However, the questions that we have in the real life is this: n, mu, and sigma. The table is for n, 0, and 1. So we have to see how we can convert the normal distribution to the standard normal distribution. Z can be calculated as follows. Assume x is a random variable with normal distribution of mu and the standard deviation of sigma. Then z is equal to x minus mu divided by sigma is a random variable whose distribution is a standard normal distribution. In other words, it has the mean 0 and the variance or a standard deviation of 1. So this is the golden formula that we have to look. Now, the normal distribution table that you have in your hand is this. The table that you have tells you this area, probability of z, let's say z0, z less than z0 is given by using the table. How we can look at the table is in this form. Your table has this type of rows and columns. I am picking up one of the values. If your value of z, let's say, is if your z0 is 1.65. 1.65. In other words, I want to know what is the probability of z less than 1.65. I have to look at 1.6 in here, and then in there I have to look at 0.05, because if I add these two I will get 1.65, right? So if you go to your table, you look at the row 1.6, the column 0.05, then you will get the number 0.95. 0.53. So this means that the area underneath the curve, this curve, which is the standard normal distribution, for z starting from minus infinity to 1.65 is this number. So this is how we look at it. But the challenge is that we have to understand that we have a normal distribution. And usually we have it in the form of mu and sigma. Then we have to calculate z. Then we have to calculate the probability. Now, if the probability of, if you calculate the probability of z, and if z is corresponding to the value of, to this random variable with this type of distribution, is that probability value is corresponding to the same probability value, or do I need to do some transformation? In other words, for x with normal distribution with mean mu and variance or standard deviation of sigma, I want to see what is the probability of x less than x0, where x0, if I put the values, I will get the value of z0. So I get this probability value. Is this probability value the same as that probability value? So let's do an example and see. And the example is this. A certain type of battery lasts on average 3 years with a standard deviation of 0.5 years. Assume battery lives are normally distributed. Find the probability that a given battery life or a battery will last less than 2.3 years. We have battery, and the battery on average lives for 3 years with a standard deviation of 0.5 years. We want to see, and it's normally distributed, because the life of the battery we can consider as a random variable. We want to see what is the probability that the batteries that are produced have the life of less than 2.3 years. Okay? So, in other words, we have a normal distribution. This is mu is equal to 3. And we want to see what is the probability that the life is less than 2.3. Now, we know that in order to do it, we have to calculate this. Probability of x is less than 2.3, which is, what was the formula? 1 over a square root of 2 pi multiplied by 0.5, integral from minus infinity to 2.3, e to power minus 2.3 minus 3 square divided by, it's x, minus x minus 3 square divided by 2 multiplied by 0.5 square dx. And we said that calculation of this integral is not cool. So what we do, we are defining z, which is x minus 3 divided by 0.5. Okay? Now, we need to know, we are converting this one to this is my z, mu is 0, This is my z. We need to know what is now the value of z0, because in case of x it was 2.3, but in case of the new distribution we have to find the value of z0, which from here we can get that z0 is 2.3 minus 3 divided by 0.5, which is 7 divided by 5, which is 1.4. Right? It's 1.4. Let me double check it. This. Of course, I have a minus. So, the probability, now the question that I asked, which was, is the probability of x less than 2.3 is equal to the probability of z less than minus 0.4? And the answer is yes, it is. The answer is yes, it is. So they are the same. It is like we are not changing anything regarding the probability. The area underneath the curve is 1. We are just reshaping it in a form, we are transforming in the form that the mu is 0 and the variance is 1, the standard deviation is 1. So, and by using table, in the table we go and look at number, this one, minus 1.4, the first value which is 0.00, and you will get to be 0.8076. So we get that the probability of x less than 2.3, which is the probability of z less than minus 1.4, is 0.8076. Now, as you see, this is very easy. Actually, normal distribution is pretty easy. But what happens is that we have to be a little bit clever because we can manipulate this type of distribution quite a lot. And before I do another example, let's see what are those type of manipulation that we can do. Now, probability of x less than a, this area, we know how to handle it. How do we know that how to handle it? We already did an example. Now, question will be like this. What is the probability of x is between A and B? In order to calculate this one, the steps are these. We are calculating the probability of Z, which is between ZA and ZB. So what is ZA? ZA is A minus mu divided by sigma, and ZB is B minus mu divided by sigma, right? And here, I need to calculate this one. In order to calculate it, it is equal to probability of z less than zb minus the probability of z less than za. Because z less than zb is all these to minus infinity. And if I subtract the green part out of it, the blue part is what is left. The blue part is what is left. Let's see, what about this one? Probability of x greater than d, it is like the probability of z greater than zd. Zd is d minus mu divided by sigma. And this is 1 minus the probability of z less than zd. This is, we use a table to find what is this value. And let's say, if you want to find this red region, then the probability of x is between c and d. It means that the probability of z between zc and zd, which is equal to the probability of z less than zd minus the probability of z less than zc, or it is equal to 1 minus the probability of z is greater than zc minus the probability of z is greater than zd. Okay? They are the same. And let's assume if this is alpha and this is minus alpha, and let's keep this standard for this class, that by this I mean that if mu is 0.5 and if this is 1, I mean this is 0. In other words, this distance is the same as this distance. Okay? This is what I try to say. Because if mu is 0, we can make sense out of it. But if it is not, I want you to understand that this is the same. So, for this type of thing, let me redraw the graph here for a standard normal distribution. This is 0. Alpha minus alpha. This area, the probability of z greater than alpha is equal to the probability of z less than minus alpha due to symmetry property. In other words, if you need to calculate the probability of z greater than alpha, of course you can always calculate the probability 1 minus probability of z less than alpha, or you can have even faster calculation by looking at this. So let's continue by doing a few more examples. And the example is continuation of our previous example. This is part A. Let's define part B of this question. And the question says, for the same battery life problem, what is the probability that a given battery will last between 1.5 to 2 years. In other words, it means what is the probability of X is between 1.5 to 2 years, which means Z of 1.5 is 1.5 minus 3 divided by 0.5, which is minus 1.5, so it's minus 3. And Z2 is 2 minus 3 divided by 0.5, which is minus 2. In other words, this is equal to probability of Z to be between minus 3 and minus 2, which we know from the first part of the board. It is the probability of Z less than minus 2 minus the probability of Z less than minus 3. From the table, minus 2 is minus 2, 0, 0. It's 0.2275 minus, minus 3 is 0.00135, which results into this is 0, this is 4, this is 1, 1, 2, 3, 4, 5, 1, 2, 3, 4. That's 0.00. Ah, I missed the 0 here. So this is 3, this is 1, this is 2, this is 0. This is that probability.
Excuse me.
Ah.
I'm quite to get it. Why do we use this 0.00?
Because the precision of this table that you have is 2 digits after the decimal point. In other words, the numbers in the table that you have is like 2.00, 2.01, 2.02. In other words, if you want to find 2.005, you can't with this table. You have to either look at this or look at this, you decide. But there are some other tables which you have higher precision, maybe 4 digits after the decimal point, 5 digits after the decimal point.
So the columns here are like
for the second digit after the decimal point. The first one is given in here, and for the second one you look at it here. For example, for 2.01, you come and look at the 2.0, and then you look at 0.01. Like at these two, you will get the number. So this table is with 2-digit decimal point. In the exam, you will be responsible for 2-digit decimal point. In other words, if you write here 0.02 or 0.021, that's okay. And this table, you will bring it with yourself, or you can print your table and bring it in the exam. But one thing is that you can have a higher precision one, so you can just stick with this precision. Let's do a part C for the same example. Which I want you to solve it. What is the probability that a given battery will last between 4.5 to 5 years? What's the answer? It's the same as this one, because if you look at it, it was 3, right? So it's 1.5 to 2, and now it's like 4.5 to 5, and they are of the same distance from the mu, because this distance is the same as this, and no, it should be this is 1, so it should be 3, 2, and this is 2, 1.5, 4.5. Come on.
4 to 4.5.
It's 1 is 4